So in this video, what I'm going to be doing is going through the remainder theorem. Now this is not really covered in all exam boards, but it's still something that you might find useful to know. Now, what is the remainder theorem, you may be asking? Now, this topic actually links to algebraic long division, where you are dividing a polynomial by a linear function. And what the remainder theorem states is that if you divide your function by x minus a, then the remainder of that calculation will be the same value of when you substitute the a value into the polynomial. And likewise, if we were to divide f of x by xa minus b, where a and b are constants, then the remainder would be the same value as if you were to substitute b over a into the function. And what I'm going to do now is go through some examples of what that actually means. So if we look at the example below, and just bear with me while I scroll this one down. So this is like a typical question. So work out the remainder of 2x cubed minus 4x squared plus 2x plus 7 when we divide it by, first of all, x plus a. So in this case, what we're going to do is we're going to work out the remainder when we work out this calculation. So in terms of part A, what it's actually doing is, if I was to divide all of this by x plus 1, then what would the remainder be? So just like when we do, let's say 21 divided by 5, then the remainder in this case would be 1. So what we're doing is we're going to find the sort of remainder for when we divide these two things together. So to do this, what we need to do is use the remainder theorem, and rather than using as an alternative for using algebraic long division, what we're going to do instead is we're going to use the remainder theorem to work it out. So for part A, what we need to do is, first of all, get a pen, is for part A is we're going to substitute f of minus 1. Now, to work out what value we substitute in, so in terms of the remainder theorem is that we had x minus a. So if we compare this to x plus 1, then our a value is going to be minus 1. So the value you substitute, so one way of looking at this is the value that you substitute is going to be the value of x, which makes that bracket equal to 0, which we've mentioned before in another video. So substituting this in, what we do is we just swap x with minus 1. So if I just write down the calculation of what we've got, so as you can see, all I'm doing here is substitute wherever I've got an x, I'm swapping it with x minus 1, and if I type that into my calculator, well actually I shouldn't need to, but let's just work this one out. So we've got minus 2, minus 4, minus 2, plus 7, which gives us a remainder of 3. And likewise for b, here I'm going to substitute the value that makes this bracket equal to 0. So here I'm going to substitute f of a half, and if I substitute that in, and this is exactly what I'm going to be typing into my calculator. I strongly recommend you use brackets when you substitute numbers in, and so if I just quickly type that into my calculator, I'm going to get 29 over 4. And there is your remainder. So in some cases you might get fractions, sometimes you might get a whole integer. So if we move on to the next example, so here it says when x cubed minus 2x squared plus 7x plus k is divided by x plus 2, the remainder is 8. So this is what we call a reverse question, where you're given the answer and you need to work out what part of the question is. So here, what this is telling me to do is that when I work out what f of minus 2 is, then what this expression is going to give me when I do that substitution, it gives me the answer of minus 8. So what I then need to do is substitute x equals minus 2 into this polynomial, and squared plus 7 lots of minus 2 plus k equals minus 8. So here I'm going to end up with minus 8, minus 8, minus 14 plus k equals minus 8. And if I simplify all of this, I get minus 30 plus k equals minus 8, which gives me a k value of 22. So obviously be prepared to work out in one way in terms of more your expected questions like the first example, but then use that knowledge to work out what reverse questions are where you kindly do the opposite.